January 17th, 1944. Peenemünde, Baltic coast. The wind cuts across the frozen estuary like a blade. In the shadow of a concrete bunker, a young Luftwaffe technician named Klaus Hoffmann watches as the first Feisler V-103, what the world will come to know as the Vergeltungswaffe 1, the vengeance weapon, roars down its launch ramp. The pulse jet engine screams, a sound like metal tearing itself apart. Flame erupts from the tail. The crude winged bomb climbs into the gray winter sky, wobbling slightly before steadying on its predetermined course toward the Baltic Sea. Hoffmann clutches his clipboard, his breath visible in the cold. Around him, engineers in leather coats and wool caps nod with satisfaction. The test is a success. The weapon is simple, brutal, and unstoppable. Or so they believe.
In the technical briefings that follow, Luftwaffe intelligence officers speak with barely concealed contempt about British radar technology. They have studied captured equipment from downed RAF bombers. They have interrogated prisoners. They have analyzed intercepts and reconnaissance photographs. Their conclusion is unanimous. British radar is primitive, cumbersome, reliant on outdated vacuum tube technology and heavy ground installations. The systems are slow, they say. The operators are poorly trained. The integration between detection and interception is clumsy, bureaucratic, riddled with the inefficiencies of a democracy at war. One intelligence report from February 1944 describes the British chain-home radar network as a collection of isolated listening posts with minimal coordination capability. Another assessment, circulated among V-weapon planners, estimates that British defenses might intercept perhaps 20% of incoming V-1s under optimal conditions. The Luftwaffe has fought the RAF for 4 years. They know their enemy, they have measured them, and they have found them wanting.
The logic seems unassailable. The V-1 flies at 400 miles per hour at altitudes between 2,000 and 3,000 feet. It is small, fast, and cheap to produce. Germany can manufacture them by the hundreds, then by the thousands. Even if the British manage to shoot down half, an absurdly optimistic estimate in German eyes, the other half will strike London, crushing British morale, disrupting war production, perhaps forcing Churchill to negotiate. The mathematics of attrition favor the attacker. 10,000 V-1s will cost Germany a fraction of what 10,000 bomber sorties would require. No pilots will be lost. No aircrew will be captured. Just steel, fuel, and high explosive, raining down on England until the resolve of the British people finally breaks. What Klaus Hoffmann and his colleagues cannot see, what their intelligence apparatus cannot comprehend, is that across the North Sea, in the operations rooms beneath the English countryside, a revolution in warfare is already underway. It is a revolution not of larger guns or faster aircraft, but of information itself, of electrons moving through circuits at the speed of light, of data transformed into decision, decision into action, action into survival. The British have not simply improved their radar, they have reimagined the entire concept of air defense as a single integrated organism, a nervous system spanning hundreds of miles, reacting faster than any human mind could coordinate, precise beyond what any manual system could achieve. The Germans are about to collide with the future, and they do not even know it exists. The first operational V-1 is launched against London on June 13, 1944, 1 week after D-Day. It is 4:18 in the morning. The missile crosses the English Channel in darkness, its pulse jet engine cycling with its distinctive buzzing roar, the sound that will earn it the nickname Doodlebug among Londoners. British radar operators at Dover pick up the contact immediately. The blip appears on their screens at a range of 47 miles. Within seconds, the information is transmitted not by telephone or radio dispatch, but through a dedicated landline network connecting every radar station, every fighter sector, every anti-aircraft battery into a single coordinated whole. At RAF Biggin Hill, air raid sirens begin to wail. At the gun operations room beneath the Dover Cliffs, mechanical computers, the Kerrison Predictor and its successor systems begin calculating intercept vectors. These are not simple rangefinders. They are analog computing machines using gears and cams and electrical servos to solve differential equations in real time, predicting where a moving target will be 3 seconds, 5 seconds, 10 seconds into the future. The guns do not aim where the V-1 is, they aim where it will be. And they adjust their fire continuously, automatically, as the missile approaches. The first V-1 evades interception and strikes Bethnal Green, killing 6 people. But the system has awakened. Within hours, RAF fighters are being vectored onto incoming missiles with unprecedented precision. Anti-aircraft guns are being repositioned along the coast. Barrage balloon cables are being raised to optimal altitudes based on radar-tracked flight paths. The British are not reacting, they are adapting, and they are doing it faster than the Germans believed possible. In the German launch sites scattered across northern France, crews work around the clock. The V-1 offensive is supposed to be overwhelming, a technological blitzkrieg that will redeem the failures of the Luftwaffe, prove that German engineering can still dictate the terms of the war. Each morning, Klaus Hoffmann and thousands like him receive reports on the previous day's launches. They read the numbers with growing confusion. Of 24 V-1s launched on June 14th, 9 are confirmed to have reached London. Of 31 launched on June 15th, 11 reached their target. The interception rate is not 20%. It is not even 50%. Something is wrong. By the end of June, British defenses are destroying nearly 70% of all V-1s that cross the coast. The Luftwaffe technical staff scrambles for explanations. Perhaps the British have deployed far more fighters than intelligence estimated. Perhaps the anti-aircraft guns are more numerous than reconnaissance indicated. The possibility that British technology might actually be superior is too unsettling to consider seriously. Germany is the land of Siemens and Zeiss, of precision engineering and scientific method. Britain is a declining empire, clinging to outdated traditions, led by men in top hats who still think cavalry charges are relevant. How could they possibly have outmaneuvered German science? The truth is concealed in windowless concrete bunkers and converted manor houses across southern England. At the Filcher Room in RAF Bentley Priory, young women in WAAF uniforms push markers across vast plotting tables, tracking dozens of V-1s simultaneously. But they are not working from verbal reports or delayed telephone calls. They are working from data fed directly from the newest generation of British radar, centimetric radar, operating at wavelengths 10 times shorter than anything the Germans have deployed operationally. These radars can track smaller targets at greater range with far higher precision, and the information flows not through human intermediaries, but through dedicated communication lines, displayed on oscilloscopes and plotting boards updated every few seconds. At Stanmore, the nerve center of RAF Fighter Command, controllers sit before display consoles that integrate radar tracks with weather data, fighter availability, gun zones, and balloon altitudes. They are not managing individual interceptions. They are conducting an orchestra of destruction. When a V-1 is detected over the channel, the system automatically assigns it a track number. Computers calculate its speed and heading. If the missile is projected to pass through a fighter patrol zone, the nearest Hawker Tempest or Supermarine Spitfire is vectored to intercept, guided not by the pilot's visual search, but by continuous radio updates based on real-time radar tracking.
If the missile evades the fighters and enters the gun belt, a 4-mile-deep corridor of concentrated anti-aircraft fire just inland from the coast, the artillery engages using predictive fire control so accurate that gunners do not manually aim. They simply load and fire. The machines do the rest. The Germans expected chaos. They encounter precision. They anticipated confusion. They meet calculation. They designed a weapon to exploit the assumed weakness of democratic inefficiency, and instead they have run headlong into the purest expression of industrial democracy, the ability to organize complexity, to value every individual contribution within a vast cooperative system, to trust machines to do what machines do best, so that humans can do what humans do best. By July 1944, the interception rate has climbed above 80%. Luftwaffe commanders are incredulous. They order new launch patterns, night attacks, saturation barrages, attempts to swamp the defenses with sheer numbers. Nothing works. For every tactical adjustment the Germans make, the British system adapts within days, sometimes within hours. When the Germans begin launching V-1s at night, the RAF deploys Mosquito night fighters equipped with AI Mark X radar, capable of tracking and intercepting targets in complete darkness. When the Germans try low-altitude launches to evade radar, the British lower their coastal gun emplacements and adjust fire control algorithms. When the Germans attempt to saturate defenses by launching dozens of missiles simultaneously, the British response is not overload, but distribution. Each incoming threat is assigned to a specific intercept layer, tracked independently, engaged in sequence. Klaus Hoffmann sits in a briefing room in late August, listening as a visiting Oberst from Berlin explains that the V-1 campaign has already succeeded, that British morale is cracking, that Churchill's government is on the verge of collapse. But Hoffmann has seen the raw data. He has read the reconnaissance reports. He knows that of the 8,000 V-1s launched so far, fewer than 2,500 have reached London. He knows that launch sites are being bombed daily, that production facilities are being targeted with increasing accuracy, that the entire V-weapon program is consuming resources desperately needed on the Eastern Front and in Normandy. He says nothing. There is nothing to say. The machinery of the Reich does not tolerate doubt. What Hoffmann cannot know, what German intelligence never fully grasps, is the philosophical difference underlying British success. The Luftwaffe has built its defense systems around the brilliance of individual commanders, the initiative of exceptional pilots, the superiority of German training and fighting spirit. The British have built their system around the assumption that no individual, no matter how brilliant, can process information faster than a machine, that coordination is more valuable than heroism, that a network of average operators using excellent tools will outperform elite warriors using good ones.
In the gun belts along the coast, young conscripts from Yorkshire and Wales feed shells into breech mechanisms, never seeing their targets, trusting entirely that the mathematical symphony occurring inside the Kerrison Predictors will guide their fire true. In the fighter sectors, pilots who 6 months earlier were flying taxi runs and ferry missions now destroy V-1s with methodical efficiency, following radio instructions with absolute precision even when their instincts scream to break formation or chase a visual contact. They have learned that the system knows more than they do, that the radar operators watching screens 50 miles away have a better picture of the battle space than any pilot could achieve with his own eyes. It is a surrender of ego, a democratization of warfare that would be impossible in the hierarchical rigidity of the Wehrmacht. The British have done something the Germans never attempted. They have turned air defense into assembly line work. Each component, radar detection, data transmission, threat assessment, intercept vectoring, fire control, is optimized individually and then integrated into a seamless whole. It is the same philosophy that allows American factories to produce a bomber every 63 minutes, that enables Liberty ships to slide into the sea 17 days after their keels are laid. It is the philosophy of mass production applied to violence, of engineering applied to survival, of democracy applied to total war. By September 1944, the interception rate exceeds 85%. German launch crews can hear the explosions as their missiles are destroyed over the channel or the coastal towns. At night, the sky above Kent flickers with anti-aircraft fire and burning V-1s tumbling into the sea. Each morning, Klaus Hoffmann reviews reports that make less and less sense. How can the British destroy 89 V-1s out of every 100 launched? How can their fighters intercept missiles flying at 400 miles per hour when German intelligence assessed British fighter response times as too slow for effective engagement? How can their anti-aircraft guns achieve hit rates exceeding 60% when manual fire control systems rarely achieve above 15%? The answer lies in technologies the Germans know exist but have catastrophically underestimated. Centimetric radar, proximity fuses, automated fire control, integrated communication networks. None of these are secret. British aircraft have been shot down carrying radar equipment. Unexploded shells have been recovered with proximity fuses intact. Captured RAF officers have described the system under interrogation, but German intelligence has consistently dismissed these reports as exaggeration, as propaganda, as the desperate boasting of a losing power. There is a cognitive trap here, one that defeats the Luftwaffe as surely as British guns and fighters. The Germans have fought the British for 5 years. They have faced their Spitfires and hurricanes. They have bombed their cities and been bombed in return. They know the British are brave but not brilliant, stubborn but not innovative, organized but not efficient. How could such a people, led by a whiskey-soaked romantic like Churchill, possibly out-engineer the Third Reich? The idea is almost metaphysically offensive. Yet the evidence accumulates. In October, the interception rate reaches 89%. Of every 100 V-1s launched toward England, 89 are destroyed before reaching their targets. The 11 that survive are not random chance. They are statistical inevitability, the irreducible minimum that any system, no matter how efficient, cannot eliminate. The British have not achieved perfection. They have achieved something far more terrifying. They have industrialized survival. In the filter rooms and operations centers, the work continues with the rhythm approaching the mechanical. Radar operators track incoming contacts, plotters update tables, controllers issue vectors, guns fire, fighters intercept, V-1s explode. The system processes destruction with the same dispassionate efficiency that a textile mill processes cotton, that an automotive factory processes steel. There is no hatred in it, no vengeance, no emotion beyond the satisfaction of a difficult job performed well. It is warfare as engineering problem, slaughter as quality control. The symbolic object that comes to represent this transformation is not a weapon or a machine, but a simple glass valve, a vacuum tube. In German eyes, the vacuum tube is obsolete, a clumsy, first-generation technology superseded by more elegant solutions. German engineers pride themselves on miniaturization, on mechanical precision, on reducing the number of components needed to achieve a result. The British approach seems wasteful by comparison. Their radar systems use hundreds of vacuum tubes, where a German system might use dozens. Their fire control computers are massive assemblies of relays and servos, where German designs are compact and theoretically more efficient. But the British have understood something that Germans have not. Redundancy is not waste. Multiplication of simple components is not inferiority. In a vacuum tube circuit, if one tube fails, the circuit degrades but continues to function. In a mechanical system optimized for efficiency, a single broken gear can paralyze the entire mechanism. The British systems are robust because they're crude. They are reliable because they are over-engineered. They are effective because they prioritize function over elegance. In the technical archives captured after the war, Allied intelligence officers will find German assessments of British radar describing it as technologically primitive but operationally effective. The phrasing is revealing. In the German worldview, technical sophistication should dictate operational success. The idea that a crude system could outperform an elegant one is almost paradoxical. Yet here, across the killing fields of the Channel sky, the paradox proves true. The British radar network, built from thousands of glass tubes and copper wires, from plotting tables and telephone lines, from human operators and mechanical calculators, defeats the V-1 offensive, not despite its primitiveness, but because of it. It is a system designed not for theoretical perfection, but for practical survival. And in war, survival is the only metric that matters. Klaus Hoffmann will survive the war. He will be captured by British forces in May 1945 and spend 2 years in a POW camp in Scotland. During his internment, he will be allowed to read technical journals. One article, published in the Journal of the Institution of Electrical Engineers, describes the integrated air defense system deployed against the V-1 offensive. Hoffmann will read it 3 times, slowly, checking the mathematics, verifying the specifications. Everything he was told about British capabilities was wrong. Not slightly wrong, comprehensively, catastrophically wrong. The British radar network was not primitive. It was the most sophisticated air defense system ever deployed. The operators were not poorly trained. They were executing procedures more complex than anything the Luftwaffe had imagined possible. The integration was not clumsy. It was seamless, elegant in its functionality, if not in its components. He will think about the V-1s he helped launch, imagining them now from the perspective of the British system. A radar pulse reflecting off metal skin, a track number assigned, a fighter vectored, a burst of cannon fire, a flash of flame as fuel and explosive detonate together. Repeat, repeat, repeat. 8,900 times. An industrial process, calibrated and optimized, refined through iteration into something approaching perfection. The final V-1 launch against England occurs on March 29, 1945. By then, the launch sites in France and Belgium have been overrun by Allied ground forces. The Germans are firing from modified Heinkel Haste 111 bombers flying over the North Sea, air-launching the missiles in a desperate final attempt to inflict damage, to justify the resources expended, to prove that the wonder weapons were not a technological delusion. The British system tracks the bombers and the missiles they release. Fighters intercept most of the aircraft before they can launch. Anti-aircraft guns destroy most of the missiles that are released. Of the last 50 V-1s launched in the war, only 3 reach English soil. 2 hit empty fields, 1 destroys a farmhouse in Kent, killing no one. The total accounting is brutal. Of approximately 10,500 V-1s launched against England, fewer than 2,500 reached London. Another 2,000 were destroyed by fighters, primarily RAF Tempests, Spitfire Mark 14s, and Mosquitoes. More than 1,800 were destroyed by anti-aircraft guns using automated fire control. Several hundred were brought down by barrage balloon cables. The rest crashed due to mechanical failure or guidance errors. The interception rate averaged 82% across the entire campaign. In the final months, it reached 89%. The V-1 was supposed to be unstoppable. It was supposed to exploit British weakness, to prove German technological superiority, to force a negotiated peace through terror. Instead, it became a test case for a new kind of warfare, one where information flows faster than aircraft, where machines calculate faster than human minds, where systems defeat weapons. The Luftwaffe called British radar primitive. The British responded not with rhetoric, but with results. 89%. In the years after the war, as historians and engineers dissect the V-1 campaign, a consensus emerges. The German failure was not primarily technical. The V-1 itself was an effective weapon, simple, reliable, difficult to intercept using conventional methods. The failure was conceptual. The Germans designed their weapon to defeat an enemy that no longer existed. They anticipated the British air defenses of 1940, manually coordinated, reliant on visual observation and human reaction time. They encountered instead the British system of 1944,
a fully integrated network where detection, decision, and destruction occurred in a continuous automated cycle. The philosophical gap was even wider than the technical one. German military doctrine emphasized the decisive importance of individual excellence, the ace pilot, the brilliant commander, the superior warrior. British doctrine, shaped by centuries of naval experience and Industrial Revolution pragmatism, emphasized the power of systems, the multiplication of modest capabilities through organization, the transformation of information into advantage. In the skies above England, these two philosophies collided. The British system did not need brilliant operators. It needed competent ones, thousands of them, each performing their specialized function within a larger cooperative whole. It was democracy as military doctrine, the harnessing of collective mediocrity to achieve individual excellence's defeat. There is poetry in the numbers, 89%. Not 100% because perfection is impossible in war. Not 50% because the British refused to accept such losses. 89% the product of ingenuity and desperation, of engineering and courage, of vacuum tubes and human determination. It is a number that represents not just tactical success, but a vindication of a way of organizing human effort, a proof that open societies can match and exceed authoritarian ones, not despite their openness,
but because of it. The V-1 offensive killed approximately 6,000 civilians and injured another 18,000. Every death was a tragedy, every injury a crime. But against the German expectation of 50,000 dead and London in ruins, against the strategic objective of breaking British will, the campaign was a comprehensive failure. The British adapted faster than the Germans could innovate. They learned faster than their enemy could teach. They turned defense into science, survival into engineering, resilience into mathematics. Klaus Hoffmann, reading that technical journal in a Scottish POW camp, understood finally what he had been fighting. Not British incompetence or democratic confusion, but something far more formidable. A society that could harness the talents of every individual within a collective framework, that could value the radar operator as much as the fighter pilot, that could trust a young woman moving markers on a plotting table to make life and death decisions in real time. The British system worked because it was built on a foundation of trust. Trust in technology, trust in training, trust in the idea that ordinary people, given the right tools and the right information, could achieve extraordinary things. The V-1 was a weapon of vengeance, born from rage and desperation. It was defeated by something more powerful, a system born from necessity and refined through cooperation, a fusion of human insight and mechanical precision, a demonstration that the future of warfare belonged not to wonder weapons, but to wonder systems. The Luftwaffe looked at British radar and saw primitive equipment operated by amateurs. They failed to see the network, the integration, the philosophy that transformed crude components into lethal effectiveness. 70 years later, the descendants of those systems fill the air around us. The GPS satellites guiding civilian aircraft use principles refined from wartime radar. The air traffic control networks managing thousands of flights simultaneously are the grandchildren of the filter rooms at Bentley Priory. The concept of network-centric warfare, of sensors and shooters linked through information systems, of speed measured not in miles per hour, but in decision cycles, all of it traces back to those desperate months in 1944, when the British turned their island into a single integrated killing machine and fed the Vergeltungswaffe into it, one missile at a time, until the offensive broke not against British morale, but against British mathematics. The vacuum tubes are long gone, replaced by transistors and microprocessors and quantum computers. The plotting tables have given way to digital displays. The young women in WAAF uniforms have been succeeded by generations of operators and analysts and engineers. But the principle endures, that information is power, that systems defeat weapons, that coordination trumps heroism, that a democracy willing to trust its people with technology and training can outfight tyrannies that trust only their elites. The Germans called British radar primitive. History called it victorious.
And in the space between those judgments lies a lesson that every generation must relearn. That sophistication is measured not by elegance of design, but by effectiveness of result. That complexity is valuable only when it enhances rather than impedes function. That the most powerful weapon is not the one that strikes hardest, but the one that strikes most reliably, again and again, until the enemy's will and capacity are both exhausted. 89%. The number stands as monument and warning, a testament to what can be achieved when a free people turn their full industrial and intellectual capacity toward survival, when they value cooperation over domination, integration over isolation, practical effectiveness over theoretical purity. The Luftwaffe looked at British radar and saw primitive equipment operated by amateurs. They failed to see the network, the integration, the philosophy that transformed crude components into lethal effectiveness. The vacuum tubes are long gone, replaced by transistors and microprocessors and quantum computers. The plotting tables have given way to digital displays. The young women in WAAF uniforms have been succeeded by generations of operators and analysts and engineers. But the principle endures, that information is power, that systems defeat weapons, that coordination trumps heroism, that a democracy willing to trust its people with technology and training can outfight tyrannies that trust only their elites. The Germans called British radar primitive. History called it victorious. And in the space between those judgments lies a lesson that every generation must relearn. That sophistication is measured not by elegance of design, but by effectiveness of result. That complexity is valuable only when it enhances rather than impedes function. That the most powerful weapon is not the one that strikes hardest, but the one that strikes most reliably, again and again, until the enemy's will and capacity are both exhausted. The war moved on. The systems remained. And the future was written not in the V-1's crude autopilot, but in the glowing vacuum tubes of British radar, in the plotting tables and communication networks, in the idea that ordinary people, given extraordinary tools and the trust to use them, could defend not just a nation, but a civilization. Not through individual heroism, but through collective brilliance. Not by matching terror with terror, but by transforming destruction into data, data into decision, decision into survival. This was the phantom shield the Germans never saw. This was the weapon that defeated the wonder weapon. This was democracy at war, imperfect and inefficient and absolutely unstoppable.